So, we shall still continue with the design of columns. So far we have done that axially loaded columns, and last class we have started uniaxial bending. Now, let us see that how that if there is a moment acting on the columns in addition to besides axial load, then what happens. So, if this is a column load P and moment M, what we can do, if we take a section, we shall get a cross section of the column. Not necessarily we shall make this column say square, we can make it rectangular also. If we have say axially loaded, then we can take it say, even we can take it say circular if it is required, square, it does not matter, rectangular also. When we are having say bending, so what we can do, we can provide that side that about the axis. There are two conventions we generally follow. One is that whenever we specify moment, we say that about the axis, or we say that along the axis. That is the only say designation. Say mx, whenever we talk say mx, moment about x, or say moment, though we are specifying that means moment about y, but we are specifying that about x. So that way also we specify. So depending on the situation, say you are talking say moment this way. If this is your say x axis, I can say like this, because this convention should be followed and it should be mentioned. So if we take say this is your section, obviously you can say this is your x axis and this is your y axis. Now you will find out that people used to say mx, people used to say my. When we are talking say mx, so obviously the question arises whether that mx is about y, that means about y, I mean to say about this particular axis, but it is acting about y. So that means as if it is along x. So other alternative also could be that about mx means about x, but it is acting that other direction. So this is the convention that it has to be clear. So let us say here, whenever we are talking say this mx, my, all those things. So what we can do, if we talk, sorry, this is your y axis. So what we can do in this case, we can say mx, we can say as if it is along x. So mx, whenever we are talking, then it is say along x. Now if that be the case, what we can do, this is your dimension b and this is your dimension d. Our objective here to resist this moment mx or m, whatever way, and p also, that axial load. So what we can do, we can increase the depth. So it may be preferable to use rectangular shape rather than square, because we have to resist this moment we have to resist. So obviously that this depth should be more. And also what we can do, shall we provide the reinforcement along this only, because then we are getting the maximum from the, because so far wherever you you put your that reinforcement, so far axial load concerned there is no problem, but so far the bending moment concerned, what we have to do, obviously since this moment acting about this axis, so what we can do, we can provide the reinforcement here, that means either at this end and the other end, that we can specify. Alternatively, what we can do, if it is required, what we can do, we can specify the reinforcement all along. So obviously we are not taking the full benefit of this say reinforcement, only it will take the axial load, but for biaxial bending obviously you have to specify the reinforcement all along, that all in all the sides you have to specify. So this is the general case whenever you are considering that one, how shall we specify that. Now what our code says, I mean, how shall we start design. So far we know that how to design that axial loaded column, but how to design that one, say your uniaxial bending, let us say. So uniaxial bending means axial load plus moment about one axis, or moment about say major axis I can say. So moment about major axis and axial load, if that be the case, then how shall we design? In that case what we do, if we come back to the strain diagram, so this is your B, D, I have told that somewhere, if we draw the diagram, so we have somewhere 0.002 and 0.0035. I repeat once more, this is very, very important. So this is your stress and this is 0.446 after the material and all other say your say partial